is an example problem that I want to highlight before. As I'm grading quizzes, I realize that there's a common misunderstanding that I want to go over. So let's say we have arc length problem. You know the formula is S equals R theta, right? S is arc length, R is radius, theta is your angle measure. If you're using this formula, anything that is here is going to be in terms of radians, okay? But I think this is where I think we probably are going to, because whenever we talk about conversion from radians to degrees, we always have that pi over 180 or 180 over pi. But just because something is in radians doesn't mean that it has to have pi in it, okay? So whatever value that you get from theta, that is already in terms of radians. There's nothing more that we need to add. It's already in radian form. It doesn't have pi in it, but it's okay. It's already built into that value. We don't have to do anything to it. So let me show you here. Let's say the arc length is given as 5 meters. The radius is 3 meters. Find the angle measure theta. All right, so S is 5, R is 3. We're looking for theta. We'll plug in, replace S with 5, replace R with 3. Theta is 5/3. That's it. That's radians. That is your radian measure. Okay. If I ask you to convert into degrees, you go through the formula here. Even though there's no pi to cancel out, everything is built in within that 5/3. So 5/3 times 180 over pi. Make the calculator do all the work for you, and then you round it to decimal value. Okay. So pi will show up if we're converting from degrees to radians or from radians to degrees. But if we're using this arc length formula, whatever theta gives you back in return, that is the radian measure. We don't have to do anything. Don't need to add pi. Whatever that gives you, that is the value of theta. Okay. So I want to bring that up. I think that's the biggest thing that I saw. Everything else, I think there were maybe some issues with finding reference angles and coterminal angles, but I think for the most part, you guys were pretty good there. It's just this kind of threw some students off. Okay, but you still, earn partial credit being able to get to that theta value. Okay, so today we're going to talk about special right triangles, and then we're also going to move into something called unit circles. Okay. Okay. So you guys remember this, right? 45, 45, 90 triangle, 30, 60, 90 triangle. Okay. Okay. So here is the relationship. Let's go over 45, 45, 90 triangle first. Okay, so the relationship here is that if I have a 45, 45, 90 triangle, it has to be a right triangle, okay, right angle. And then the other two angles are always equivalent to each other, and they're always going to be 45 degrees. So a couple of the other notations that you might see for 45, 45, 90 triangle is this. That's enough for it to be a 45, 45, 90 triangle. Okay, there's no markings on it except for that. That's a 45, 45, 90. Here's another 45, 45, 90. That marking is also enough to demonstrate 45, 45, 90, because 90 degrees, equal angles, there's no other variation for this except for 45, 45, 90. Okay, so it doesn't have to explicitly state it's a 45, 45, 90. These markings by itself would be enough. Okay, but here's the relationship. The legs are always going to be the same length, okay? And the hypotenuse is always the longest side. The hypotenuse is going to be the side across from your 90-degree angle, and it's always going to be x. It's going to be the leg times root 2. So whatever the leg length is, multiply that by root 2, and that will get me to the hypotenuse value. If I want to go from the hypotenuse back down to the leg, I'm going to divide by square root of 2. So you're either multiplying to get to a larger value, or you're dividing to get to the smaller value. And then root 2 is going to be the way that we get from one side to the other. Okay, so let's try this problem here. I'll call this number 1, number 2, and number 3. Okay, 45 degrees is showing, 90 degrees showing. We know this must be 45 as well. We know that the legs are the same length. I'll mark them as 8 and 8. And the hypotenuse is going to be longer than the leg by √2. So we just take the leg, multiply by √2, and that's going to be the length of my hypotenuse. Okay, number 1. Okay, we're on page 26. Okay, page 26 in your packet. Number 2, it's also a 45, 45, 90 triangle because they're indicating that these lengths are the same, and it's a 90-degree angle. So it's a 45, 45, 90, even with no angle measure showing. What's given to us is the hypotenuse. So if I want to make my way from a hypotenuse back down to a smaller value, the leg value, not square, yeah. So from the leg to hypotenuse, I multiply by square root of 2. To get from hypotenuse back down to leg, I divide by square root of 2. So divide by square root of 2. You can make the calculator rationalize this for you, or you can work it out by hand. Okay. Any questions with 1 or 2? Okay. Number 3 also falls under the category of a 45, 45, 90 triangle because the markings and that 90-degree box indicates this must be a 45, 45, 90. We know that we're looking at are the leg values. So we know 10 root 2, 10 root 2, those are the legs. I want to find hypotenuse. So here's my formula. I need to take the leg value, multiply by square root of 2, and that will get me to the hypotenuse. Okay, what's root 2 times root 2? Yeah, root 4, which is 2, and then 2 times 10 is 20. Okay, questions so far? Okay, we're going to do these next 3 examples, but these 3 examples are with a 30, 60, 90 triangle. So I want to highlight the relationships here with each of the legs or each of the sides of a 30, 60, 90 right triangle. First off, we have the short leg. The short leg is going to be the one that is across from the smallest angle, the 30-degree angle. Okay. Next up is the long leg. The long leg is going to be across from your 60-degree angle. And finally, the longest side is your hypotenuse, and that's going to be across from your 90-degree angle. Okay. So short leg and hypotenuse has an easy relationship. It's always going to be half or double, depending on where you're starting from. And then the long leg is going to be root 3 times longer than the short leg. So typically, if I'm trying to find a missing side of a 30, 60, 90 triangle, and I'm not given the short leg, I always want to involve the short leg because that even though it kind of takes a little bit longer, it's just more straightforward. So that means if I have this long leg value and I'm trying to figure out the hypotenuse, I'm always going to get to my short leg first and then worry about finding the hypotenuse. So think of your short leg as your bridge calculation to get from one value to the other. So basically, if I want to get from short leg to long leg, I'm going to multiply by root 3. If I want to get from long leg to short leg, I'm going to divide by root 3. If I want to get from short leg to long leg, I'm going to multiply by 2. Sorry, short leg to hypotenuse, I'll multiply by 2. If I want to get from hypotenuse to short leg, I'm going to divide by 2. So always involve the short leg when you want to get from hypotenuse to long leg or long leg to hypotenuse. It makes things easier. You don't have to worry about trying to do multiple operations at once. You just kind of do one thing at a time and kind of work your way around. Okay, so. Okay, so let's call this 4, 5, and 6. But it's kind of small on my paper here, so I'm going to write this out on a separate sheet so you guys can see clearly my work. Okay, so x 60, y 22. Okay, if that's 60, I know this must be 30. So 30, 60, 90 right triangle. I'm going to label these here. This is my short leg. This y must be my long leg. And then 22 must be my hypotenuse. Okay, so this is a little bit easier because it's giving us a hypotenuse that we can use to help us get to the short leg. And then from the short leg, we can get to the long leg. So how do I get from hypotenuse down to the short leg? Yep, divide by 2, right? Short leg and hypotenuse always has that double half relationship. So 22 divided by 2, 11. Now that I'm at the short leg, it's going to be easy for me to transition to any other size I'm looking for. So now that I know my short leg is 11, to get to my long leg, just take the short leg and multiply by √3. Okay, any questions there with number 4? Okay, number 5. Okay, so I'm going to label this here. Across from the 30 is my short leg. Across from the 60 is the long leg. Across from the 90-degree angle is my hypotenuse. Okay, so we're starting at the long leg. So the best thing to do is to get to the short leg first, and then it'd be easier to get to the hypotenuse. So always involve short leg if you're trying to do any movement around finding sides of a 30, 60, 90. So here's my long leg, which is 15. How do I get down to the short leg? Divide by √3, right? So just think, if I want to get from a larger to a smaller value, I'm always going to be dividing. If I'm going to try to get from a smaller to a larger value, I'm going to be multiplying. Okay, so to get to my short leg, I'll take the long leg and divide it by square root of 3. That's what the rule says, right? It's going to help us get down to the short leg. This is not rationalized, but we can make the calculator do it for us or multiply it by hand. Okay, so now that I have the short leg, how can I get to the hypotenuse? Multiply by 2, yeah. 2 times 5√3 gives me 10√3. Okay, number 6. All right, let me label the sides here. This is the short leg, long leg, hypotenuse. Okay. I'm given the hypotenuse. I always want to involve the short leg. as my first calculation. So how do I get from hypotenuse to short leg? Divide by 2. Yeah. Now that I have the short leg, how can I get to the long leg? Yep, times root 3, right? Short leg to long leg multiplied by root 3. Root 3 times root 3 is just 3. 3 times 9, 27. Okay, any questions? 4, 5, and 6? Okay, does anybody still need to look at this page? Okay, let's look at the last problem here on this page. A manufacturer wants to make a large clock with heights of 30 centimeters. What is the length of each side of the frame? This is actually an equilateral triangle, 60 degrees all the way around. This 30 is split in half. But if we can find the length of one of these, then we know the length of all three. Okay, so we're going to work towards finding the length of the side of the frame. But I think the easiest thing to do is I'm going to break this into just a 30, 60, 90 triangle and just see what I can find from this portion. Okay, so there's my 30, 60 degrees. I know it says the height of, let's see, manufacturer wants to make a larger clock with a height of 30 centimeters. All right, what is the length of each side of the frame? So we'll let the height be 30. And let's call this X and let's call this Y. Okay. All right, so here I'm starting with a long leg, right? Making my way around. Always involve the short leg first. Okay, how do I get from 30 down to the short leg? Divide by root 3, right? Getting from a long leg to a short leg, I'll divide by root 3. Divide, right? Yeah, so this is the long leg to short leg. We want a smaller value, so we're going to divide. Okay, so X equals 30 divided by root 3. Make the calculator do the work for you, or you can work this out by hand. So 30 root 3 divided by 3. 30 and 3 reduces to be 10. 10 root 3 is X. So now that I'm with the short leg, how can I get to the hypotenuse? Take this 10 root 3 and do what? Times 2. So Y is equal to 2 times 10 root 3. So the hypotenuse ends up being the same length all the way around. This is an equilateral triangle. So every side is going to be 20 root 3. And you can convince yourself too, because this is X, 10 root 3, 10 root 3 adds to be 20 root 3. So the side of frame is 20 root 3 centimeters. Yes, question. Oh, right. Yeah. So this is an exact value. It did ask you for a decimal value. So let's do that. 34.6. Thank you. All right. Any questions? Okay, next page. This is going to be your homework page, but I just want to do a few just to help you get started understanding how to work through this maze. And then I want to be able to start unit circle a little bit. I want to kind of get ahead so we kind of have some time to let that topic sink in. But I want to at least help you get started so you know how to work through the rest of the homework. Okay, so what we're going to do is we're going to start with the box that says start. We're going to solve for x. When we solve for x, we'll then know which path to take to move to the next problem, and then so on and so forth until we make our way around the maze until we get to the end. So, okay, let's do the first few to kind of help you get started. Okay, so first we're starting with a 45, 45, 90 triangle. We have leg values given. They're both 9. So what's the hypotenuse going to be? 9, what? 9? 9
square root of 2.
Yeah, 9 square root of 2. Okay, so x equals 9 square root of 2. So once you know that x equals 9 square root of 2, then you know that you're going to choose the next box based off of the correct answer. So we're going to follow this path. Okay, so now we're going to solve this problem. 30, 60, 90 triangle. We're given a short leg. To get from the short leg to the long leg, we multiply by what? Root 3. So x equals 9 root 3. Okay, looks like that's the only choice we have anyway, so go down to this box. Okay, we're given hypotenuse. Hypotenuse down to the short leg. What do? Divide by 2. X equals 14. Takes us to the next one. 14 is hypotenuse. We want to make from hypotenuse back down to the leg of a 45, 45, 90 triangle. So we do what? Divide by root 2, which can be cleaned up to be 7. Yep, so it's 14 root 2 over 2, which is 7 root 2. Okay, and you guys can finish the rest. Okay, and just keep going until eventually it takes you to the end box. Okay. So finish that later, but I want to go to page 28 and 28 to 30. Okay, so page 28. So page 28, this is a little bit of an intro to unit circle. So with unit circle, we're going to have to understand how to arrive at these major angles, special angles, in terms of degrees as well as radians. But I don't want us to memorize this, okay? We are going to build it, but I want you guys to build it understanding the pattern and then build it from scratch. But I don't want you to have to think about it in terms of memorizing. It's a lot easier just to know a few things and to be able to understand the pattern and just build it from that pattern. So we're going to work our way to this point, okay? Okay, page 29. Okay. These are the values that's going to show up on our unit circle. I'll talk a bit more about the purpose of unit circle, but right now we're just going to think of these as individual problems and see if we can arrive at these values, and these values are going to show up on the next page. So these are all triangles that have hypotenuse of 1. Okay, they all are triangles with hypotenuse of 1. Let's fill out the size of these triangles, and then we'll figure out sine, cosine, and tangent. Okay, SOHCAHTOA for each of these values. Okay, so 45, 45, 90 triangle. I'm starting with hypotenuse. How do I get down to the leg? Divide by root 2. Okay, divide by root 2. So 1 divided by root 2. It's not very clean. We can rationalize the denominator. So we get root 2 over 2. Both the legs are the same values, so copy them down twice. Okay. Now, let's talk about sine, cosine, and tangent of these respective angles. So sine of 45, it doesn't matter which angle you choose. I'll choose the bottom one here. Sine is opposite over hypotenuse. So what's sine of 45 going to be? What's opposite? over 2, all over 1. All right, so that over 1 is just going to disappear. So it's just root 2 over 2. So having the hypotenuse being 1 is helpful. It just allows our value to just be focused on our x and y values. Okay, cosine of 45. What's cosine of 45 going to be? Yeah, so adjacent over hypotenuse. The hypotenuse is we can just leave that out because divided by 1 is the same thing as not having to show it. Tangent, what's tangent going to be?
1.
Good. Opposite over hypotenuse. Sorry, opposite over adjacent. So root 2 over 2 over root 2 over 2. These are the same things equal to 1. Something that we're going to use later on is understanding that tangent is sine over cosine. Okay. Sine over cosine was also going to take us to the value for tangent. So if I take the value for sine divided by value for cosine, that will also take me to tangent. Okay, all right, let's build. So these values we're going to show up. We're going to see show up on the next page. Let's go to a 30, 60, 90 triangle. We have the hypotenuse. Let's fill out these values here. Let's do the easy one first, the short leg. Hypotenuse is 1. What's the short leg going to be? Divided by 2, right? So just 1/2. Okay. Now that we have the short leg, let's build a long leg. What's the long leg going to be? Multiplied by root 3. So 1/2 times root 3. We can also think of it as root 3 over 2. Okay, sine of 30. Opposite over hypotenuse. What's sine of 30 going to be?
1/2.
Just 1/2, right? The hypotenuse is 1, which is nice. We don't have to worry about that denominator. Cosine of 30. Adjacent over hypotenuse. Tangent of 30. So tangent of 30, opposite over adjacent. The denominators are the same, so we can just kind of cover them up. We know they're going to cancel each other out. So it's just 1 over root 3. All right. But 1 over root 3, I know it's not as cleaned up as it could be. We can rationalize the denominator, and we get root 3 over 3. Okay, 30, 60, 90 triangle from a different perspective, but 30 across, starting with hypotenuse to the short leg, we get 1/2. Long leg is still root 3 over 2, but now we are looking at sine, cosine, tangent from a 60-degree perspective. Okay, what's sine of 60? Root 3 over 2. Cosine of 60? 1/2. Tangent of 60. Good. Opposite over adjacent. The 2's can cover up. No need to rationalize the denominators, just root 3. You see that similarity here between 30-degree angle and 60-degree angle? The cosine of 30 equals sine of 60. Sine of 30 is equal to cosine of 60. We're going to see that relationship more and more when we talk about graphs. But right now, just want you guys to observe that. Okay. Now, we're going to build this unit circle here. This looks like a mess. This looks daunting, but I want to kind of talk about how we can build this from scratch just with a few pieces of information. Okay, so let's go to page 30. Right now, I'm not going to talk about yet about the purpose of unit circle. We're going to kind of get all the details out of the way, and we can be able to know how to interpret it. But first, just know that the reason why we call it a unit circle is because this is going to be a circle with a radius of 1 unit. The nice thing about radius of circle of 1 unit is going to force the hypotenuse of all these triangles to be 1, and that'll just make all of our values a lot easier. We're able to get the simplest form of ratios. Okay, so let's start off with the easiest thing that I think we all understand, which is degrees. Okay, so here you see that little degree notation here along the outer circle, slightly inside the circle, we're going to put all the degrees. Okay, so we'll start with 0 and 360. We know that 0 degree or 360 is just a full rotation around the circle, but it's going to end up in the same place. Okay. All the quadrants, let's do all. So we know this is 90 degrees. We know this is 180. We know this is 270. Back to 0. Okay. Now, all the special angles that we're dealing with, 30, 45, and 60, they all go in their respective spots here. So 30 degrees, 45, and 60. Okay. Now, we're going to build our way around the circle. Let's start with the easiest one. I think the easiest one is starting with the 45. So if you want to use your calculator, you can do this. Just keep adding 45. And if you see a duplicate, then just keep moving to the next one. So 45 plus 45 is 90. We keep going. 90 plus 45 is
135.
Yeah, so we're going to hit all the middle angles. Okay, so 135 plus 45, we get 180. That's a duplicate. Plus 45, we get 225. 225 plus 45, we get 270. That's a duplicate. Plus 45, we get 15. Okay. Okay, so now let's do the angle that's furthest away from the x-axis, the 60-degree angle. So 60 plus 60 is 120. Plus 60 is 180. That's a duplicate. Plus 60 is 240. Plus 60 is 300. Plus 60 is 360, right? Back to our starting point. Okay. Now, we're going to see a lot of duplicates here, but from 30, we're going to keep adding 30. So 30 plus 30 is 60, 90, 120. What's next? 150. Okay, so that's an open slot there. 180. What's after 180? 210. 240, 270, 300, 330. Okay. So we're good with degrees, right? No struggles there. Okay. Now the inner circle, let's talk about radians. Okay, so these are the special angles around. So we know 0 to 2 pi. 2 pi is going to allow for the full rotation around the circle. Okay. And let's just think about the quadrants here. So if I divide 2 pi by half, I get 1 pi. So I'll just put pi here. If I take 1 pi divided by half, I get 1/2 pi. So pi over 2. So pi over 2, 1 pi. What's this one down here? 1.5 pi or 3 pi over 2. Okay. Okay, don't let the pi's throw you off. Just think of it as, just look at the fractions in front, right? You got 0, 1/2, 1, 3/2, and then 2. Okay, now here are the special angles here. We have pi over 6, which is correlated with 30 degrees. We got pi over 4, and then we have pi over 3. But don't let the pi's throw you off. Just think 1/6, 1/4, and 1/3. Okay. So I'm just going to add, I'm going to start with the middle angle here. I'm just going to keep adding 1/4. If I see duplicate, I'll pass over it. Okay. So 1/4 plus 1/4 is 2/4. That's duplicate. 2/4 plus 1/4 is 3/4. So that's going to go in that middle slot there. 3 pi over 4. 3/4 plus 1/4 is, yeah, duplicate. 4 over 4 plus 1/4 is 5/4. 5 pi over 4. 5/4 plus 1/4. Yeah, 6/4. That's duplicate. 6/4 plus 1/4. 7/4. Open slot. 7/4 plus 1/4. 8/4, which is 2, and that takes us to our beginning point. Okay. All right, let's start. Let's go to the angle that is furthest away from the x-axis. 1/3. 1/3 plus 1/3. 2/3 right here. And these will all end up being the angles furthest away from the x-axis. Okay, 2/3 plus 1/3. 3/3 duplicate. 3/3 plus 1/3, which is 4/3. Okay, so 4/3, 4 pi over 3. 4/3 plus 1/3, 5/3 over here. 5/3 plus 1/3, 6/3, we're back to 2. Okay. All right. A lot of duplicates for this last one, but we'll just skip over if we see duplicates. Okay. 1/6 plus 1/6, 2/6, 3/6, 4/6. What's next? 5/6. There it is. Open slot there. 6/6.
7.
Okay, 7/5. That's an open slot. 7/6, 8/6, 9/6, 10/6. Okay. And then after 11/6, 12/6, back to 0. So no need to memorize these angles. If you know the starting points, you can just keep adding fractions all the way around until you get to 2. Okay, good so far? Okay. Now, all these, there's order pairs associated with these. I'll talk about what those order pairs are going to mean. But for now, I just want to give you a little way to memorize or to build these order pairs. Okay. So these are all going to show up as order pairs. They're all going to be related to these values that we just found. But rather than finding all those values, I just want to kind of help build it, showing you patterns, so that we can kind of get to the more important things. All these order pairs are going to have denominators of 2. So just do that. You know that they all will have over 2. There's no need to figure anything out. Just think, you know, everything will be divided by 2. Okay. Now, starting at the upper left corner, we're going to start with 1 and we're going to count. We're going to say 1, 2, 3, shift over, and then go 1, 2, 3. Okay, so these are going to be cosine and sine values for these angles, and we're not going to have to build everything from scratch. We can just memorize this and fill it in. Now, all the numerators has a radical, but what's square root of 1? Just 1. So we're not going to put a radical above 1. We're just going to put radical above all the other numerators. So root 3, root 2, root 2, root 3. Okay, easy enough, right? Okay. Now, all these order pairs will just keep duplicating themselves all across the rest of the unit circle. Okay. So everything with pi over 4, anything with a 4 in the denominator will have these order pairs. So I'm going to copy everything with the 4 in the denominator. Basically, all the middle angles are going to have root 2 over 2. Okay. Anything with a 3 in the denominator will have this order pair, 1/2 root 3 over 2. So find everything with 3 in the denominator and copy those order pairs over. Okay. The sign is going to be different, but we'll talk about the signs in a little bit. Anything with the 6 in the denominator will have this order pair, root 3 over 2, 1/2. Oops, sorry. Okay. And I forgot to do the easiest order pairs here. This is, think of this as 0, 0. This is unit circle, so everything is 1 unit away. What's the order pair for this point here? It's just going to be 1, 0. So it's 1, 0. Okay. What's the order pair for this point here? 0, 1. Okay. Order pair here, -1, 0. And the order pair down here, 0, -1. Okay. All right, we're almost done. We're almost done. Everything in the first quadrant, order pair, what are the x and y values? Signs. Everything is positive in the first quadrant, right? So no need to adjust any signs here. Everything is positive here. What does order pairs look like in the second quadrant? -, Positive. So we're going to make some adjustments. All the x values you wrote down in second quadrant, put a negative in front. Third quadrant, all the order pairs are what? Negative, negative. So force all the order pairs to be negative, negative. What's the order pair for fourth quadrant? Positive, negative. Okay, so just change the sign of the y value. Okay, so this is going to be helpful as we find values involving sine, cosine, tangent, anything that we need. This is also going to help us with graphing. But first things is understanding and not being intimidated by this, just knowing that, okay, if I know a few things, I can just build, I just have to know my first quadrant, do that little trick that I showed you, and they can build out the rest. You know relationship of order pairs, you know relationship of signs, and we'll talk about the significance of this tomorrow. But tomorrow we're going to try to practice, see if we can build this from scratch, so that hopefully it won't feel less intimidating after seeing it today. Okay. Okay. Few minutes left. I want to open up map testing for those who can try to finish. If we can't finish today, I'll set it up again tomorrow. But I'll set up map testing for the remaining time that we have. One second.